Hey guys, and welcome back to some more Further Pure 1 revision. Today we're going to take a look at Conic Sections 1. So, definitely not as fun as part 2 of this, where you're looking at kind of ellipses and such, but still equally important. Okay, so, the marks, just as important for this part compared to Conic Sections 2. So, let's take a look at what we've got. So, basically in this video, we're dealing with parabolas and rectangular hyperbolas. So, first question here is dealing with a parabola. So, let's take a look at this. So we're given this parabola C, which has the equation y squared is equal to 4x. We're given the point S, which is the focus of C. So we're asked to find the coordinates of S for part A here. So S is the focus. So this formula here is given in your formula book, but it's really not too crazy. If you've got a general parabola, y squared equals 4ax, okay? Well, comparing that to ours, y squared equals 4x. In that case, 4a is equal to 4. Well, in that case, a is just 1. 4 divided by 4 gives you 1. So the coordinates of S, the focus, well, the focus is just a is 0, and in our case, a is 1. So the focus, for our question, so the coordinates of S are just 1, 0. Okay, so that's part A done, nice and easy. Part B, so we're given the point P here, which has y coordinate 4, and we're told that it lies on the parabola C. So if we have the y coordinate, we can easily work out the x coordinate. So to do that, all we do is substitution. So y is 4. So all we do is we substitute that into y squared equals 4x. So 4, we're going to square that, so that's 16, that's equal to 4x. So just solving this linear equation now, we get x equals 16 divided by 4, which is nice and easy, just gives us 4 there. So the x coordinate of P is just 4. So part C, a little bit more work to this one now. We actually have to find an equation for the line L, and the line L passes through S and P. So what I'm going to do, just to make sure we have enough room, is just to clear everything. So let's start with this one. So it passes through S and P. So let's just write down what S and P are again. So S is 1, 0. And P, which we just worked out, was 4, 4. So now we're going to use this information to work out this question. Well, the first thing we're going to do is work out the gradient. So if we've got 2 points, we can work out the gradient. So this should be nice and easy. So m, so that's going to be 4 minus 0 divided by 4 minus 1. Okay, 4 minus 0 is 4, 4 minus 1 is 3. Okay, so we get the gradient 4 over 3. So now we've got the gradient, all we need to do is just use one of the points, and using the formula for the equation of a line, so y minus y1 is equal to m lots of x minus x1. Using that now with one of the points, we get our line. So once we've got that line then in this form, we just need to manipulate it to get it into the form that they asked for. So at this stage here now, so if I substitute my point in, I'm going to substitute the easiest one to be would be s, which is 1, 0, so that's going to be y minus 0. That's going to be equal to 4 over 3 times x minus 1. Okay, that's y equals 4 over 3 times x, so 4 over 3x minus 4 over 3. Now they want it in the form ax plus by plus c equals 0. And the other little point to be careful of is that they want a, b and c to be integers. So what we're going to do here now is just times through by this 3 here to get rid of my denominators. So if we do that over here, that's going to give us 3y is equal to 4x minus 4. And then finally, they just want it in the form ax plus by plus c equals 0. So if I just take this 3y across here, I get 4x minus 3y minus 4 equals 0. And there we have it. So that is the final answer there. That's our line L. So part D, we're told that L meets C again at the point Q. So we're just asked to find the coordinates of Q. So if I clear this question is quite big, it takes up a lot of the screen, so I'll have to keep erasing it. So for part D here, we're given, our tool basically is we've got the line L, which meets C again. And don't forget, C is just our parabola that we started with. So L, that's 4x minus 3y minus 4. And we also have C, which is y squared equals 4x. Now, if these two lines, or these two lines intersect, then they're going to be equal to each other. So we can just use some substitution here, equate them, and then just start solving to get our coordinates for Q. So what I'm going to actually do here is, if you notice, y squared is equal to 4x, all I can do then is just rewrite L in terms of 4x, and then just substitute it into C here. So that's 4x equals 3y plus 4, and then substituting that into here, what I get is y squared is equal to 3y plus 4. So at this stage now what we've done is we've got it in terms of just y, so we can now just solve for y. So getting this equal to 0, that's going to be y squared minus 3y minus 4 equals 0. Factorising this now, hopefully, it looks like it should do, and it does do. So we get y minus 4, y plus 1 is equal to 0. So therefore, we've got two solutions for y here. Y is either 4 or y is equal to minus 1. Okay, we've already obtained the y equals 4 solution. That was the 4, 4. So we don't need to bother with this one. We just need to consider this y equals minus 1. So that's the point Q. So Q is y equals minus 1. So all I need to do now is substitute this back into my my parabola C. So doing that, so y squared, when y is minus 1, minus 1 squared is equal to 4x. Well, just solving this now, I get 4x equal to 1, which means x equals a quarter. Nice and easy. So your coordinates of Q, if we write them down fully, they are a quarter, that's your x coordinate, and then minus 1. And then finally, for part E, we're asked to find the distance of the directrix of C to the point Q. Well, the first thing we should probably do here is just write down the directrix. So this is given again in your formula, but you don't have to worry about memorising it, but it's really quite easy to remember. So the equation for directrix is x plus a equals 0. And remember, a is just your focus. So our focus here was a equals 1. So in this case, this is x plus 1 equals 0, which we can write as x equals minus 1, if we want it in terms of x. Well, to give a better idea of what we're actually looking for here, let's just draw a quick sketch. So we'll just ignore the bad artwork. So we've got this line here, x equals minus 1. So that's going to be this line here. And what we want to find here is the distance from the directrix here to the point Q. And we know Q is a quarter minus 1. So that's going to be somewhere like here. Okay, that's Q there. Okay, so that's a quarter minus 1. So we just need to find this distance here. So how would we do this? Well, consider this is the line x equals minus 1. So to get from this point here to the y-axis, that's just a distance of 1. And then to get from the y-axis to Q, that's just a distance of a quarter. So to get the total distance, all we have to do is just add these together. So therefore, total distance is just the sum of them. So just 1 plus a quarter, which is the same as 4 over 4 plus 1 over 4, which gives us 5 over 4 there. Okay. So in the end, that gives us our final answer. The distance from the directrix of C to the point Q is 5 over 4. And that gives us the full solution to that question. So let's take a look at the next one. This question is taken from one of the old exam papers. So it's basically the exact same material. The ordering just kind of slightly different when they used to do it, but the material just the exact same. So we're given a parabola C again, which has this time the equation y squared equals 16x. Part A just asks us to verify that our point does lie on this curve, or the parabola C. So how would we do that? So it's 1 mark. Shouldn't expect anything too crazy. So all we actually have to do is just substitute in this coordinate here, this point. And what we should expect is if that y squared is equal to 16x, once we substitute that point in, the left-hand side should be equal to the right-hand side. So 8t squared, that's my y coordinate, so y squared is equal to 16 times x, where x is 4t squared. Okay, so if we simplify this now, that gives us 64t squared, which is equal to 16 times 4 t squared, so that gives us 64t squared there. So left hand side is equal to right hand side, so therefore the point P is a general point. On C, nice and easy, just for 1 mark there. Okay, so that was part A. Part B, if we just do it over here, we've got plenty of room. We just want to write down the coordinates of the focus S of C. So again, just like the last one, you've got your general equation, and the focus is A0. So now, using your general equation, compare it to what we've got. So we've got y squared is equal to 16x. Well, in that case, what we're saying is 4a is equal to 16. So we've just got to solve this now. A will be 16 divided by 4 to give us a equals 4 there. So therefore, the coordinates of the focus are just going to be 4 and 0. Okay, so again, just using standard rules, standard formulas, nothing too crazy. Now part C, this is where we need to start doing a bit of mathematics. We want to write down the normal to C, P. And we're actually given the equation, so we know what we should be aiming for. So, just like we would with our regular A-level maths, when we're working out the equation of a normal or a tangent, we want to differentiate, right? So, we need the gradient here. So differentiation is a good way of obtaining that. So we need the gradient. So what we've got here is y squared equals 16x. Well, we want to differentiate this. So at the minute, this y squared equals 16x is a little bit tricky. So what we're going to do is we're going to square root both sides. So if you square root both sides here, well, that'll just be y. So the square root of y squared is just y. Square root this, so square root of 16x. We can write that as 16x to the half. But you need to square root this as well. So sorry, that should be the square root of 16x. So you get 4x to the half. Okay, so that's 4x to the half. And now at this point, we just differentiate this here. So dy by dx. This should hopefully be nice and straightforward. We're just going to get 2x and subtract 1 off the power to get minus a half. But our normal to C is at P, and we know P has the coordinates 4t squared 8t. So our x coordinate is 4t squared, so we need to consider this in terms of x, which is 4t squared. So this is 2 lots of 4t squared to the power of minus a half. Well, if you simplify this, this is just the same as 2 over the square root of this expression here, which if you simplify, you'll get 2 over 2t. If you simplify this one step further, we get 1 over t. Okay? But just be careful here. So this is the gradient at the point P, using x equals 4t squared. But we need we're looking to get the normal. So we don't use this as our gradient. We need the negative reciprocal. So therefore, gradient of normal is equal to minus t. Okay, so our minus t is the gradient we're going to work with. So now, all we need to do is use the equation of a straight line. So y minus y1 is equal to n lots of x minus x1. Using this gradient and just substitute a point in, which is this point here, P. Okay, so therefore, y minus 8t is equal to m, where m is minus t lots of x minus 4t squared, because that's our x coordinate. Okay, and at this point here, we're basically just simplifying and just manipulating to get it into this form. Okay, so y minus 8t, that's equal to minus tx plus 4t cubed, so just be careful with the negative signs. So minus t times minus 4t squared, we get positive 4t cubed. So at this point here, this is looking pretty good. We've got y minus 8t is equal to minus tx plus 4t cubed. And if you notice their expression, that's y plus tx equal to 8t plus 4t cubed. So at this point here, if you can spot it, all you've actually got to do is add 8t to both sides and then add tx to both sides here. So we get the final solution of y plus tx is equal to 8t plus 4t cubed there. And there we have it. So that is a normal to C at the point P. So for 5 marks for that, I don't think there's anything too crazy. Just be careful with your differentiation. So there we have it. So that's that question done. Now let's take a look at another question from the textbook. So this is kind of a proof style question. These are quite common with conic sections. You can prove quite a lot of different properties and such. So for this question here, there's quite a few different things going on. We've got a point P, which has the coordinates x, y, and it moves so that its distance from the point 5, 0 is equal to its distance from the line with equation x equals minus 5. So we want to prove that the locus of P has an equation of the form y squared equals 4ax. We need to find that value of a. So I think the best thing to probably do with this kind of question is to just draw a bit of a diagram just to kind of see and illustrate what's going on. So I'm terrible at sketching on this little tablet, so I'll try my best. See what we get. Okay, so let's just say that's our axes. So we've just got a regular parabola here. So let's just draw that. It's going to look something like this. Okay, my artwork's terrible, but it's going to look something like that. We're also given this x equals minus 5, so this is going to be probably our directrix, right? So minus 5, so that's going to be that's x equals minus 5. And we're also given the point 5, 0, which is looking like it's going to be our focus, right? So if we say, let's just say that's the 5, 0. Okay, that's S. And then we've also got the point P, which moves, so its distance from 5 to 0 is equal to its distance from the line x equals minus 5. So that's actually going to lie here on the parabola. So we say that's there. So that's P, which is xy. So the question's essentially asking, can we prove that the distance from this point here is equal to the distance of them there? Now, I've kind of drawn it a bit rough, but that's essentially what we're looking to show here. So how would we do such a problem? Well, let's consider just the definition of a parabola. So using the definition of a parabola, and let's write down what we actually want to prove as well. The first thing is that we want to show that S to P is equal to P to N. So sorry, this is my point N here. Okay, so we want to show that S to P is equal to P to N. Now, when you're working with distances, it can be tricky if we're involving square roots, right, which the distance formula does. So one way to get around that is by squaring the distances, okay? So if we consider doing that, we're going to do SP squared is equal to PN squared. So now we can use this, the fact that we're squaring these distances here to make life a lot easier. So again, let's just write down what S and P are. So S is 5, 0, and P is XY. Okay, so the distance squared, which is equal to SP squared. So let's use the distance formula now. Well, the distance from S to P, so that's going to be x minus 5. So x minus 5 all squared plus y minus 0 squared, which would just be y squared, obviously. So if we simplify that, that's just going to be x minus 5 squared plus y squared. At this point here, everything looks good. I don't see any mistakes, hopefully. So now let's keep going. We'll see if there's a mistake after it doesn't simplify nicely. So now we need to consider P to N. Okay, so the distance from P to N. What would that be? Well, P to N is even easier. If you consider this distance here, well, from the y-axis to P, that's just a distance of x, and then from N to the y-axis, that's just 5. So in total, that total distance is x plus 5. Okay. Well, we want SP squared is equal to PN squared. Well, PN is x plus 5, and we know what SP squared is, that's this here. So, equating these now, x minus 5 squared plus y squared is equal to x plus 5 all squared. And at this stage here now, we just need to expand and then simplify. And what we should hope for is that we get something in this form here. Y squared is equal to 4ax. Okay? Well, expanding your bracket here, we get x squared minus 10x plus 25 plus y squared. This is equal to x squared plus 10x plus 25. Okay? This stage here, just start simplifying. The x squareds will cancel, the 25s will cancel, so all we're going to get left with here is minus 10x plus y squared is equal to 10x. So, writing this in terms of y squared now, we get y squared is equal to 10x plus another 10x, or 20x, like so. And notice now we do have it in the required form, okay? So that's y squared equals 4ax, so 4a is equal to 20, so in our case, a must be 20 divided by 4 to give us 5. Okay, so we have it in the required form. Have it in the required form where a is 5. And there we go, so that's that question fully done. Definitely not an easy question. I think it's kind of just understanding what the question's actually asking for, but there we go, so you should get a equals 5. And then if we move on to the very last question here, this question is on a rectangular hyperbola. So, hyperbola, I can't speak. So we're given the equation, xy equals c squared. And part A just asks us to write down the y coordinate of A. So we're told the point A has the x coordinate 3c. So at the minute, this is 3c, y, for A. Well, how would we do that? Well, this equation here, if we just sub in our x, we can simplify this. So this is 3c, because x is 3c, y equals c squared. And to simplify this, put it in, rearranging for y here, we get y equals c squared over 3c. You simplify that, you get c over 3. Okay, so the actual coordinates of A are 3c and then c over 3. So that's part A done. And then part B, another question where we need the equation of the normal. So let's just clear this just so we've got enough room to finish it. Let's have a go with it. So part B here. So we've got y equals c squared over x. So I'm just rearranging my formula there. So c squared over x. So the reason I'm putting it in terms of y is because, again, we're looking for a normal. We're going to differentiate, okay? We're differentiating to get that gradient. So if I put it in terms of y, I can now just differentiate this. But remember, to make life a bit easier, this is c squared times x to the minus 1. So if you differentiate this, that will be minus c squared x to the minus 2, like such. which you can rewrite again, just to make life a bit easier in a minute, as minus c squared over x squared. So we've got all that now. Now we can work out the gradient. And we know it's at the point A. So A is 3c 3 over c. So x squared, that's going to be 3c squared, so we can substitute that in. Over x squared, so 3c squared. That's minus c squared over 9c squared. At this point here, we're just simplifying, right? So we get left with minus 1 over 9. But be careful, just like we did with the previous one, we were working out the equation of the normal, we need the perpendicular gradient here, or the negative reciprocal. So, gradient of normal that will just give us 9. So now we've got the gradient, we have the point, we just need to start rearranging and substituting our point in. So, using y minus y1 again, we can write this as y minus 3 over c. That's equal to m lots, so m is 9 times x minus x1, and x1 is 3c. So at this point here, we're just doing a lot of, simplifying. So that's y minus 3 over c. That's equal to 9x minus 27c. So it's 3y is equal to 27x minus 80c. So the first thing I can see here, I've done something wrong. Oh no. Okay. This should be c over 3. So sorry about that. So that's c over 3, which means have I done everything else right? So this is fine. This part's wrong. I was going to say this doesn't work. So that should be 3 over c. And that should be c over 3. I'm still getting it the wrong way around. Okay. Right, let me just rub that out because this is terrible. Right. Let's fix this. So this is c over 3. Okay. So now we can simplify, okay? Because I'm going to say this doesn't work, but it does now, okay? Timesing through by 3, we get the 3y. So this is 3y minus c is equal to 27x. Okay, it's really throwing me this, 27x minus 81c. And if you notice, we've just got one line extra here now. All we need to do is add c to both sides. So therefore, 3y is equal to 27x minus 80c. And there we have it. Okay, so I was starting to make the mistakes at the end, but we've got there. So that's our equation of the normal. And that brings us to the end of this video. So I hope this has helped. If you notice any more mistakes, because there probably is, please let me know down below. But cheers.